Hey guys, so in the last lecture we were discussing methods to measure the efficiency. So we discussed direct method. So we will start with today indirect method. So in direct method we see just the formula was output upon input. So it doesn't give the information about where the loss is happening. So in indirect method we get the information of where the losses are happening. So so the first, these are the various losses due to which the efficiency is reduced. So the first loss is sensible heat loss in flue gas. So here L1 is considered sensible heat fuel loss, that is Q is equal to mcp delta T, where m is mass of air supplied per kg fuel, air supplied of kg fuel plus mass of fuel burnt. So so this loss is indicated here mcp delta T upon cv of the fuel. So this is the loss, sensible heat loss in flue gases. Then the second loss is loss due to moisture in flue gases. So if there is moisture in the flue gases, then there will be a heat loss. So here TF, here the formula to find the loss is m into 584 plus 0.45 into TF minus TA upon CO of fuel. TF and TA are temperature of fuel and air respectively. Then the next losses due to heat loss due to moisture in fuel itself. So this was moisture in flue gases and this is moisture in fuel. So heat loss due to evaporation of water formed due to hydrogen in the fuel. So if hydrogen is there in the fuel, so to evaporate that water, some heat is wasted. So that is the loss. Then there is heat loss due to opening in furnaces. So heat loss can be calculated by considering black body radiation. So as we know that black body radiation E is uh, is equal to sigma B into T raised to 4. So here the formula will be sigma B into T raised to 4. That is black body radiation at furnace temperature. T is furnace temperature, and multiplying this with emissivity and the factor of radiation through openings, and K is the factor of radiation through openings. Then the next, heat losses due to furnace skin. So there are two methods in which you can calculate this. So first method is by using this mathematical formula given below. Here this here the total heat loss is the sum of natural convection and radiation. So these T is to 4 terms are for radiation and these terms are of convection. So here A, small a, this A is the factor regarding direction of surface of natural convection. So it has to be taken for ceiling as 2.8, for side walls is for 2.2, and for hearth it is 1.5. The second method can be use of graph for calculating the loss through skin of furnace. So either use equation or the graph. Then last is unaccounted losses. While considering other losses, that is heat storage loss. So if you are storing the heat, then that kind of loss of furnace gases. So if the furnace is having all gases inside it, 4, so that can be the loss. So the total efficiency can be measured as 100 minus L1, L2, L3, L4, L5 and L6. So the this is how we can calculate the efficiency. So how we can optimize these furnaces? So to optimize the furnaces, we should provide temperature controllers, and we can ensure that flame does not touch the stock. So it should not touch the stock. Improve burner design, match the load and capacity, retrofit with heat recovery devices, and use ceramic fibers in the case of batch operations. Ensure that furnace chamber is slight positive pressure. So in this way we can optimize the furnaces. So now we will discuss one furnace, that is Cupola furnace, to understand how the furnace works. So we will go one by one for construction, then charging, then working, advantages and limitations. So Cupola furnace is used for melting scrap metal or pig iron. Metal or pig iron for production of various cast irons. The Cupola furnace has very several unique characteristics which are responsible for widespread use of melting unit for cast iron. Cupola furnace consists of water-cooled vertical cylinder which is lined with refractory material. So we will go with construction. So the construction of a conventional cupola furnace consists of a vertical steel shell which is lined with refractory bricks. So as you can see in this diagram, so the upper portion is spark arrestor, so which will be which cannot be seen uh, for now, so just remember it. So the charge is introduced into the furnace body by means of opening approximately halfway up to the vertical shaft. So this is the charging door where charge is introduced. The charge consists of alternate layer of metal to be melted, coke fuel and limestone flux. Metal flux coke, metal flux coke. So alternate layers. The fuel is burnt in air which is introduced through tires positioned above the earth. So here the air is being inletted to the tires which is positioned above the earth. So the hot gas is generated in lower part of the shaft, ascend and preheat the descending charge. So this is the construction. Now how the charging happens. So before the blower is started, the furnace is uniformly preheated. So we'll preheat the furnace, and then metal and coke charges lying alternate layers are sufficiently heated up. The cover plates are positioned suitably and blower is started. So the height of the coke charge in the cupola in each layer varies from 10 centimeter to 15 centimeter. 10 to 15 centimeter. The requirement of flux to the metal charge depends upon quality of the charged metal and scrap. So how much fluxes uh, required depend on the quality of metal and scrap, the composition of coke, and the amount of ash content present in the coke. So now we will see working. So how this cupola furnace will work. So the charge consisting of metal alloying ingredients, limestone, coal coke for fuel, and so charge is having limestone, coal coke and for fuel, and carbonization 8 to 16% of metal charge. So after charge is fed, air enters the bottom through tires extending a short distance into the interior of the cylinder. The air inflow often contains enhanced oxygen levels. So coke is consumed. The hot exhaust gases rises up through the charge, preheating it. This increases the energy efficiency of the furnace. The charge drops and is melted. So this charge will drop and is melted. Although air is fed into the furnace, the environment is reducing one. Burning of coke under reducing conditions raises the carbon content of. So as the material is consumed, as this material is consumed, additional charges can be added to the furnace. A continuous flow of iron emerges from the bottom of the furnace. So iron will emerge from bottom of this furnace continuously. So depending on the size of the furnace, the flow rate can be as high as 100 tons per hour. As metal melts, it is refined to some extent, which removes contaminants. This makes this process more suitable than electric furnaces for dirty charges. So it is more suitable than electrical furnaces. A hole higher than the tap allow slag to be drawn off. So slag will be drawn off. So the exhaust gases emerge from the top of the cupola. Emission control technology is used to treat the emission to meet the environmental standards. So what are the advantages and disadvantages of this furnace? So it is simple. So it is simple, economical to operate, high melting rate. Melting rate is very high. Ease of operation, adequate temperature control, chemical composition control. Cupolas can refine the metal charge, removing impurities out of slag. Cupola is capable of accepting a wide range of materials without reducing melt quality. From life cycle perspective, cupola are more efficient and less harmful to the environment than electrical furnaces. The continuous rather than batch process suits the demands of repetition foundry. So continuous process is more suitable than batch process. Efficiency of cupola varies from 30 to 50%. What are the limitations? So since molten iron and so the limitations are that since it is molten iron and coke are in contact with each other, certain elements like silicon, magnesium are lost and others like sulfurs are picked up. This changes the final analysis of molten metal, and close temperature control is difficult to maintain. So the last topic of this furnace topic is furnace balance sheet. So heat balance sheet helps the operator to numerically understand the present heat loss and efficiency and improve the furnace performance using those data. So identify the sources of heat loss. It is necessary to prepare heat balance sheet. So these are the types of heat losses which are considered for heat balance sheet. It is quantity of heat in steel, then sensible heat in flue gases, then moisture and hydrogen loss of fuel, heat losses by incomplete combustion, it is CO loss, heat loss in cooling water, then heat loss in sensible heat of scale, then heat loss in openings and radiation and other unaccounted losses. So we need to prepare a heat balance sheet. So a balance sheet will be prepared keeping two columns. Here we'll put input and here output. So all these losses will come here in output one after another, and in input will come combustion of heat of fuel. Then total on both the sides should be matched. So that is called balance sheet. So in this way we can control the heat loss. So this is the method by which we can uh, improve the efficiency in furnaces. So in the next, so this completes the furnace topic, and from the next lecture we will start insulation and refractories. So how we can conserve the heat in insulation, how we can conserve the energy in insulation and refractories, and what are the types of insulations and refractories. So hope to see you in the next lecture. So thank you very much.